At this point, we will now be investigating the velocity or the speed time graph. So we have here in the figure a velocity time graph of an object. The x-axis represents time and the y-axis represents the velocity of the object. We have divided the graph into three regions. Later on, you will find out the reason for doing so. Okay, so as what we have learned last time, if we take the slope of the graph, it would give us another entity or another quantity. Okay, so in this case, if we take the slope, okay, taking the slope of a velocity time graph would give us the acceleration. Okay, simply because the slope of a velocity time graph is change in velocity or the speed over the change in time. Okay, that is the slope of a velocity time graph, which is the acceleration. Okay, so in this example, we take 2 points. Let's say this is point P and this is point Q. Okay, so to determine our slope, that would give us change in velocity or change over change in time. So that would give us v2 minus v1 all over t2 minus t1. Okay, so we will have point P as our final point and point Q as our initial point. So for velocity, we will have 30 minus 10, and for time, we would have 6 minus 2. So the slope would give us 20 over 4, which is 5. And the unit would be meter per second squared. Okay, that would be the slope at phase 1. Okay, so what would be the interpretation of this slope? What would it gives us about the motion of the object? So if we have a slope of 5 meters per second squared, it tells us that the object's speed is increasing at a rate of 5 meters per second per second. Or saying it in another way, that the speed of the object increases at a rate of 5 meters per second for every unit of time, which is in this case we have used seconds. Okay, thus giving us a positive slope which leans to the right. Okay, now how about the slope for phase 2 or region 2. Can we obtain a slope from this one? Obviously, the slope for this one is 0. Why? Because the line is parallel with the axis of time. Okay? So if the line is parallel with the axis of time, as you can see here, it's really parallel, we cannot obtain any slope. What does it mean? Well, it means that the object is not accelerating. The object has a constant speed. In this case, the object's speed is 30 meters per second. The object was able to remain at that speed from the time 6 seconds up to 12 seconds. Okay? Now, let's go with the slope of the third phase or the third region. What would be the slope? In this case, the slope would be negative. Right? This would give us a negative slope. Because this is going to be your first coordinate, and then this is going to be at any point here can be chosen as your second coordinate. Okay? So for the change in velocity over change in time, for the third region, that would give us 5 minus 30 divided by 22 minus 12. So in this case, it is very evident that we would have a negative slope, because this one, the denominator, would give us negative 25 divided by 10, and upon simplification, that means to say this is negative 2.5 meters per second squared. Now, what does it mean? What is the physical interpretation of the negative sign? It means to say that the object's acceleration is slowing, or the acceleration is decelerating. That is what it means to say. Okay? So, if the line or if the slope is leaning towards the left in a velocity time graph, it would mean to say that the acceleration of an object is actually slowing, or the object is actually slowing down because the acceleration is negative. Okay? Another thing which is notable for the velocity time graph is that through the use of the velocity time graph, we can also determine the total distance covered by the object. Okay? So how are we going to do that? To determine the total distance covered, we will just find the total area under the curve. What curve? The entire curve of the velocity time graph. Okay? So, to get the total area, okay, the total area of velocity time, that would be adding the area of the first or the of for the first slope plus the area of the second line and the area under the third line. Okay? So if we are going to isolate the first slope, we could see that the first line is actually in the shape of a triangle. So to get the area of a triangle, we will be using the formula for area 1. We would be using the formula 1/2 the product of the base and the height. In this case, that would be 1/2 and the base is 6 and the height is 30. Okay? So, upon doing the mathematics, we could see that this one is 90 in its value, or 90 meters. For area of the second curve, the shape is actually a rectangle. Okay? So to get the area of the rectangle, you just multiplied what? You will just multiply the width and, in this case, the height. So the width is 6 and the height is 30. So therefore, the area for the second graph is 180 meters. Now for the area of the third graph or the third line, as you can see, it is also a triangle. So we will have again base times height. But in this case, this is a different base. So that would give us 12 times the height, of 30. In this case, the answer is 180 meters. So, to get the total area, we just add these three, 90 plus 180 plus 180. That would give us a value of 450 meters. Therefore, the total distance covered by this object is 450 meters. I hope you understand the properties of the velocity time graph.